Unit 3, Systems of Equations. Welcome. Let's learn a little. Let's go to work. First, in Unit 3, we're going to talk about solving systems of equations. Before we get into how to solve them, what are systems of equations? Well, systems of equations are when you solve two or more equations or inequalities simultaneously. And simultaneously means at the same time. Now, in this, we are going to teach you multiple methods. Today, I'm going to focus on by graphing. Okay? But there's going to be a total of 3 methods. We will have the elimination method, we will have the substitution method, and today's lesson, graphing method. All 3 different ways. Now, here's the interesting thing about solving systems of equations. It depends on what the system looks like as to which method you would choose. Some systems are set up beautifully for the elimination method. Some systems are set up beautifully for the substitution method. And of course, some are set up beautifully for the graphing method. If you know all 3 methods, then you can choose, hey, this is the appropriate one. If you don't know all 3 of them, each of the methods work no matter what your equation looks like. It's just sometimes it creates more work. So we're going to start today by using the graphing method. Some would say that this is the least accurate method, especially when doing it by hand. But with technology today, it's really not at all. And simply stating, to solve a system using the graphing method, we will graph all equations. Now, you can choose which way you would like to graph them. Like, do you want to do a T-chart and graph it? Do you want to do slope-intercept form? Let me write it like this, y equals mx plus b. Because here we're going to be dealing with linear equations, but at some point we could have linears and quadratics, or linears and cubics, or cubics and quadratics. So it can all go together. It doesn't matter what type of equations we're dealing with. But today, and in this section, we're still going to be dealing with linear equations or straight lines or equations to the first degree. So when we use the graphing method, we graph all the equations. And then we look for a point of intersection. That point of intersection is the solution. Now, there's a couple things that can happen here. Let's say I have these 3 graphs. Lovely. Okay, and I've got these lines here, here, and here. Let's assume those are all beautiful and straight. Get a little ahead of myself. I should be neater maybe. Okay, let's say I have this second line. This one over here, that wasn't very straight. There we go. That point of intersection right there is the solution to this system. And this particular equation or system has one solution. Now, this is what we will see the majority of the time. This is probably the most common that we're dealing with. But we could also have one that looks like our second one here, where we have 2 lines that are parallel. And if we have parallel lines, there is no solution. And there's no solution because there is no point of intersection. And finally, we could have two lines that essentially are the same line and basically lie right on top of each other, right? And if they're the same line, they're said to have infinitely many solutions. Okay. Now, there's something really neat about these two, and that's the fact that since they're parallel or the same line, they literally have the same slope. So anytime that we deal with two equations and we can see quickly that they have the same slope, we know that it's either going to be no solution or infinitely many. But we'll come back to that in just a moment.